About 3 years ago, NASA's Perseverance rover touched down on Mars, marking the initiation of a long-term mission aimed at unraveling the mysteries of the red planet. The chosen landing site, Jezero Crater, was selected due to its past geological features, which included a substantial lake and a river delta. Perseverance, armed with sophisticated cameras and an array of scientific instruments, has diligently undertaken its mission of exploration, spending its Martian days studying the diverse surroundings and collecting intriguing samples of 3.5 billion-year-old Martian rocks and soil strewn across the crater floor. In adherence to the mission's design, Perseverance has deposited 10 sample-filled tubes on the Martian surface. These samples are destined to be retrieved by a subsequent robotic mission, set to transport them back to Earth for more comprehensive analysis, a process slated for the 2030s. Recently, NASA celebrated the achievement of a significant milestone, Perseverance completing 1,000 Martian days on Mars. This longevity, equivalent to 24 hours and 37 minutes each, attests to the rover's robust performance and endurance. During a press briefing on December 12, NASA unveiled preliminary findings from the analysis of the collected Martian rocks. Notably, some of these rocks exhibit a rich composition of carbonate minerals and minuscule silica grains. According to Morgan Cable from NASA's Jet Propulsion Laboratory, this combination resembles a protective environment, akin to a mummy's tomb, capable of preserving organic molecules from the distant past. Additionally, there's a noteworthy presence of iron phosphate, a substance vital for life as we understand it, providing compelling evidence that phosphorus, a key element, was accessible in a form conducive to life. Ken Farley, the project scientist for the Perseverance mission, expressed confidence in the mission's success, stating, "I would say, mission accomplished." The rover has indeed acquired high-quality samples, providing a glimpse into Mars' ancient geological and potentially habitable history. Looking ahead, the rover is embarking on a bonus mission set to take it beyond the crater's rim and into unexplored terrain. This next phase, scheduled for the coming spring, holds the promise of unveiling new facets of Martian geology. Scientists are particularly intrigued by the possibility of discovering rocks much older than those encountered thus far, shedding light on earlier stages in Mars' evolution. Libby Ives, a member of the Perseverance team, elucidated on Jezero Crater's dynamic history, detailing 3 transformative phases that occurred over billions of years. These phases involve the intrusion of a large, fast-moving river, the formation of a deep lake, and a subsequent colossal flood that left massive boulders scattered across the crater. This geological tapestry provides valuable insights into how Mars transitioned from a potentially watery environment to the arid desert landscape observed today. Despite Mars' transformative history, water that once filled Jezero Crater and other parts of the planet eventually vanished into space. Ken Farley attributed this disappearance to the influence of solar storms from Mars' young sun, gradually stripping away the planet's once thick atmosphere. As the atmosphere diminished, so did Mars' surface water, culminating in the barren and cold desert-like conditions we see today. Hidden Harbor, a spot on the Martian surface with fine-grained rocks and evidence of ancient water activity, has captured scientists' attention. Meenakshi Wadhwa, the principal scientist for the Mars Sample Return (MSR) mission, emphasized the importance of studying such rocks grain by grain, considering them vital for their strategic and scientific value. The MSR mission, spearheaded by NASA, aims to bring Perseverance's samples back to Earth, a task scheduled for the 2030s. Lori Glaze, director of NASA's Planetary Science Division, stressed the significance of returning these samples to Earth for in-depth analysis in well-equipped laboratories worldwide. The samples will serve as a benchmark, providing a ground truth that complements decades of remote sensing and in situ data collected during Mars exploration. Despite the ambitious goals, the MSR mission faces challenges, including cost overruns and architectural considerations. The mission team is currently evaluating options for returning the samples, with potential adjustments to the planned trajectory. Lori Glaze affirmed the importance of perseverance in overcoming challenges, underscoring the potential impact of this mission on scientific understanding. In conclusion, the Perseverance rover has not only met but exceeded its primary objectives on Mars. The exploration continues, offering the promise of uncovering further insights into Mars' geological past and potential habitability. The return of samples to Earth remains a pivotal goal, with the MSR mission poised to contribute significantly to our understanding of Mars and its place in the cosmic narrative for generations to come.